Okay. So
Sir,
let me just, of course, the topic of today is importance of mineral deposits. So I don't know, somehow something is missing. So let me just very briefly, because already you had sufficient knowledge of geology and geophysics. So let us just try see very broadly what are the different types of mineral deposits that are there in the field. When you go to the field, what all you see? Okay. So if you see mineral deposits, of course, as you know, mineral deposits are nothing but deposits where you have concentration of certain elements or components which are useful for society and which can be used to extract metals and minerals for industrial purposes. Okay. And the minerals are of different types. Okay. So I think probably you must have studied certain processes. Okay. So you have mineral deposits of magmatic. Okay. So you have mineral deposits of magmatic, sedimentary, and metamorphic. So these processes they operate to produce different types of mineral deposits. Okay. To take magmatic, of course, as all of you know, magmatic deposits are mostly formed under the deep-seated conditions, very high temperature and pressure, which are called as plutonic. Of course, all of you know. Okay. And plutonic, you have different types of rocks, like the granites, which can host copper, molybdenum, tin, wolfram, uranium, and to certain extent gold also. And another important rock type which shows number of mineral deposits called carbonatites. I don't know, did you study in igneous petroleum carbonatites? Rhythm? I have to note down
no,
the
sir.
different names.
No,
Did you
sir.
study carbonatites?
No, sir.
Yeah, carbonatites are just like carbonate sediments. You have carbonate sediments where a lot of calcium carbonate is there, like calcite. Okay, you have igneous rocks where you have very high amount of calcite. So they are called carbonatites. Okay, the calcium and carbonate contents are very high. That's why they are called as carbonatites. And these rocks carry very high amount of rare earth elements. It's very important. I think probably you must be studying in newspaper a number of articles. Many of the IT sector, many of the computer revolutions are based on certain components. So you have to have REE, very important, rare earth elements. Okay, and you have certain rocks called anorthosites. Okay, they host iron, titanium, vanadium. All these things are very important for industrial purposes. And other than the felsic and intermediate rocks, you have another rock type called mafic rocks. Okay, I don't know whether how many of you have heard of these terms called like, of course, basalt is very common, like gabbro, okay, dunite, peridotite. Okay, these rocks, they number of times they consist of chromium, nickel, platinum. Platinum is one of the most valuable metal next to gold. Sometimes they say that it is more valuable than gold. Okay, so these type of rocks are associated with this type of mineral deposits. So that means if you have magmatic rocks, okay, you classify them into different types like felsic rocks, you have the intermediate rocks and the mafic rocks, and these rocks can have different types of mineral deposits. The next is called sedimentary deposits. Of course, all of you know those who are coming from Madhya Pradesh are coming from Indo-Gangetic alluvium. I don't know how many of you have gone to Rishikesh, Haridwar. Okay, so many of the rocks are sedimentary rocks. Okay, they are formed by purely by sedimentary processes. I think probably Dr. Bhattacharya must have taught you. Did you have a course of sedimentary petrology? I think the GLT
Yes,
students
sir.
are, yeah, even GPT also. Okay. So you have different types of sediment, like detrital, non-detrital. Okay. So all these deposits, they have carried different elements. Like for the detrital, okay, you have uranium, sandstone type, gold, the most famous placer deposit of South Africa. It's called as Rand deposit. Okay. Tin, sometimes tin, it brings tin also. Thorium, wolfram. So all these minerals can occur in these detrital sedimentary rocks. And another group is called chemical sediments. I don't know how many of you have heard of the chemical sediments like limestones. Have you ever seen limestones?
Yes,
Pure
sir. Yes, sir.
pure limestones. They are chemical. For example, if you talk about sediments, most of the sediments they are formed in the aqueous environment. Okay, right from your pebbles, conglomerates, sandstone, shale, limestone. So if you see the sedimentary basin, depending on the depth of the sedimentary basin, you will have different types of rocks. Okay, so when you go to the deeper part of the basin, you will have mostly the carbonates because they are precipitates, chemical precipitation. So when the sediments are dissolved, slowly it will settle down. So they are called as chemical sediments. Not only you have the most famous limestones, you have some of the most famous iron deposits, manganese deposits, and sometimes even the uranium deposits, and even evaporites. So they are associated with chemical sediments. The most classical example is called as the banded iron formations, from which you have the iron deposits. The most famous Daiteri in Orissa, Kiriburu in Jharkhand. If you go to Madhya Pradesh, of course now it is not part of Madhya Pradesh, it is Chhattisgarh. The most famous the Dalli Rajara. And if you go slightly south towards Jagdalpur, whether any one of you are from Jagdalpur side, Chhattisgarh? Chhattisgarh? You are the most famous Bailadila deposit, Bacheli, Kirandul. So all these associated with the chemical sediments. Then comes the sin sedimentary exhalatives, the lead zinc deposit of copper and copper. The most famous Rampura Agucha, Rajpura Dariba, even sometimes the Zawar deposits, they are all called as sin sedimentary exhalatives. They're called as SADAX type of deposits. So where you have exhalations as well as sedimentary process. And finally, the weathering processes. The weathering also can give rise to deposits like aluminum, nickel. Okay, the most famous deposit eastern coast, Orissa, some parts of Andhra Pradesh, even Tamil Nadu. If you come towards west coast, Kerala, of course, you have most laterites. Then you come to Karnataka, you have a lot of bauxite deposits. Go to Maharashtra, once again you have bauxite deposits. Come to Vindhyan, Madhya Pradesh, a lot of bauxite deposits. Then go to Jharkhand, once again bauxite deposits. So all these are produced by weathering processes. So where there you will have aluminium, and sometimes you will have nickel also. In fact, Orissa, the most famous Sukinda deposits. Basically, they are ultramafic rocks. When the ultramafic rocks are subject to weathering, they produce a lot of nickel. So you have different types of mineral deposits in different types of rocks. Then comes metamorphic. Metamorphic is slightly high temperature process. Okay, so metamorphism is confined to three types. One is called as contact metamorphic deposits, which are called as scones, where you have tin, wolfram, molybdenum, iron, and the regional metamorphism can produce graphite, some aluminous silicates like kyanite, sillimanite, andalusite. Okay, sometimes you may even get ruby. Okay, because what is corundum? Corundum is Al2O3. When you have very high concentration of Al2O3 in a sedimentary rock that can be subject to metamorphism, it can give a lot of corundum. And if the corundum is pure good grade, then that can give rise to ruby, sapphire, okay, gemstones. And the metamorphogenic is related to metamorphism, but you have a lot of hydrothermal process coming. You have gold, silver. So different types of rocks can create different types of mineral deposits. So these are something like, and in magmatic you have separate volcanic type. In volcanic you will have continental volcanics, you have ocean floor volcanics. In continental you do not have much. Though some minerals are reported, but not much. You have most of the deposit, volcanogenic massive sulfide deposits. So the most famous Cyprus deposits, Kroko deposit, Japan, they are all considered volcanogenic, where you have volcanism, at the same time you have a lot of undersea water. So when these type of exhalations are happening, you can have different types of mineral deposits. These are the sketches, of course, when we are studying, we will go in more details. So these are called chimneys in the subsurface conditions. It creates a lot of
The slide is not changing.
not changing. Just see.
सर आपने सर आपने पावर पॉइंट की विंडो शेयर किया ना, तो स्लाइड शो शेयर नहीं हो रहा.
Is it 1 minute? Let me see. But how is it possible?
अब चेंज हो रहे थे.
देखो. That means the internet is very slow. Is it right? Is it seen now?
सर आपने भी स्लाइड शो स्टार्ट किया क्या?
हाँ, slide show, yes.
सर स्लाइड शो वर्क नहीं कर रहा, मतलब हमें प्रेजेंट नहीं हो रहा वो.
Okay, we will go only in that other mode. Are you seeing something now?
Yes sir.
Okay, so I think I will go ahead with this only. So of course, these are some of the structures. If you see the oceanic crustal structure, so you have certain deposits like chromium, nickel, platinum, volcanogenic massive sulfide deposits. So all these things occur in an oceanic environment. So when geologists, when we try to study the rocks, you try to find out whether the rocks are formed in oceanic conditions or in the continental conditions. Accordingly, you can find out what type of mineral deposits can be available in a particular area. So these particular small section of an area where you have andesite type of rocks, then you have a lot of rhyolites. These are basically volcanic rocks, but you have a lot of stockwork, a lot of crisscross veins, and it can produce a lensoidal body. So these type of deposits called as the lensoidal massive sulfide deposits, which can be formed in a volcanic environment in a oceanic conditions. So these are the different stages of the formation of volcanic deposits. We will study as we go more and more into the codes. So this is the world map showing the different types of deposits, especially the volcanogenic massive sulfide deposits in different places. You see in American continent, in North America, okay, you do have little bit in South America. You have a lot of things in Europe, okay, a lot of deposits in Australia. You have one deposit in Africa. You have few deposits in India. So like that, we geologists try to classify, we try to identify what are the places where we get different types of deposits according to the genesis. So these are called porphyry type of deposits. Basically, they are granites. Okay, you have the granitic rocks, the plutons. So in certain conditions, when the oceanic crust is getting subducted, the mafic rocks can melt and it can come to the surface. And during the process, a lot of geological process happens, and finally it produces a deposit called as the porphyry deposits, which are mostly famous for copper. If you go to South America, you find a lot of deposits. Yeah, these are the major type of, you see, all along the American continent, you have huge deposits of porphyry type, mostly copper, okay. You do have in China, a lot of porphyry is coming up. But fortunately in India, we have only one, though there are 3 deposits marked here, but somehow there is only one in Madhya Pradesh, which is called as Malanchkand copper deposit. Okay. You do have along the oceanic conditions here. So you do have a lot of deposits in different continents. So geologists, we try to study the rocks and try to find out what type of deposits can be associated with different environment. So these are the processes. So this is another deposit called iron oxide copper gold, where you have the iron component, copper as well as gold. This type of deposits, they can have and even have uranium also. So this is the most famous deposit in Australia called the Olympic Dam. This Olympic Dam is one of the most important dams, and I think about 25% of uranium comes from this particular deposit. So these are the different, these basically kimberlite. Okay, of course we are going to study kimberlite as a part of the magmatic deposits, so which are produced in the deep mantle conditions, mostly produced as part of the plumes. Then finally it comes to the crustal part. It crosses the moho, it comes to the crustal part, it gets emplaced, where it produces the ultramafic rocks, and they have the host diamonds. So we will study diamond genesis in a more careful way, in a more detailed way. So these type of deposits are basically veins. When you have rocks, when the rocks are subject to deformation, and certain fluids will come and they will occupy the spaces. So this type of filling is called as open space filling. We will study more. Okay. So mineral deposits can be produced by different processes. It can be produced by a simple magmatic process. It can be produced by a metamorphic process, by sedimentary process, and hydrothermal processes. So a lot of things happens in the deeper part of the crust. You can bring metals. Of course, this is a part of the sedimentary terrain where you have a lot of, for example, limestones, cherts, all these things are there. But a certain part of this sedimentary terrain carries certain mineral deposits, which are part of the sedimentation process. Yeah, I was talking about SEDAX type of deposits, which are called as the sedimentary exhalative deposits. One is called pure sedimentary deposits, another you have the exhalative deposits. When it is combined, it is called as the sedimentary exhalative deposits. In a particular oceanic condition, marine basin, sometime you will have volcanoes at the same time sediments coming from the continents. So when both they mix, they produce type of deposits. The Rampur Agucha deposit, Rajasthan is considered a SEDAX type of deposit. Yeah, this is a map showing SEDAX type of deposits. Yeah, we have in Rajasthan, a lot of deposits in Australia, one deposit in South Africa. There are few deposits in in American continent. So geologists, we try to understand the rocks. We try to find out tectonic conditions, metamorphic conditions, thermal conditions. So all these conditions were favorable for formation of certain deposits, and that's why we try to study in the field. Let me show this. Yeah, this is called an MVT. This is called Mississippi Valley type. Oh, this is a very special type of deposits which are there in Europe and some parts of America, North America. We have one deposit here. Fortunately, we do not have. Our is considered to be MBT type of deposit. Somehow we have not been able to discover. Okay. So basically, these are once again sulfide deposits with copper and lead and zinc. I don't know, anyone is from Orissa? This batch? Anyone from Karnataka? I think I'll find out the state from which most of you are coming from. Nikhil, where are you from?
Rajasthan.
Rajasthan. Okay. Some of Rajasthan does not have a iron deposit. So anyone from Orissa? Anyone from Goa? Anyone from Raipur? Oh God. If you people are not coming from these areas, then what geology you will do? What geophysics you will do? So this particular one is called a superior type of Barandine formations. Of course, when you are going to study about Barandine formation, we will study about superior, we'll study Algoma type, Raffian type. So there are different types of iron formations which are characteristic. When you try to study those rocks, you'll find out whether they belong to superior type, they belong to Algoma type, because superior type carries a lot of iron deposits. So this type of studies are very useful to classify the deposits. Accordingly, you can explore. Yeah, these Algoma type, mostly in Canada. In India also we do have, in Kolar, Hatti, certain parts of South India we have the Algoma. Slightly they are older type of deposits. Once again, a sedimentary, chemical sediment. Yeah, this is called supergene oxidation one. What happens is, sometimes the mineral deposit formed at the surface, at the bottom, they will be coming to the surface because of exhumation. I think probably you must have studied a lot of exhumation, tectonic processes. Okay, so when the deposits formed at the bottom, the deeper part of the crust, when they're exposed to the surface, they're subjected to a lot of oxidation because it interacts with meteoric water. When it interacts with meteoric water, it will start leaching. It will start carrying the metals. So at the surface, you will have bosons, mostly iron. Then you will have a lot of leached zones. You can have certain metal components, and you have supergene enrichment here below the water table. So these places are more favorable for mineral deposit discoveries. So you have to study, you have to understand. Yeah, yes, this is the section. See, at the top you will have the hydrate iron oxides, a lot of copper carbonates, oxides, silicates. chalcocite, covalite, boronite, all these are basically copper-bearing minerals. And when you go to the bottom, you'll have the primary ore, like chalcopyrite, pyrite. All these things carry a lot of metals. You'll have copper, lead, zinc, sometimes gold also. Yeah, of course, this gives the details. We will not go into much details. Yeah, this is very interesting. If you go to the field, you will come across this type of structures. So these are called as the cellular boxwork structures. So based on that, you can find out below this particular structure, you can expect certain mineral deposits. So this gives an indication, this is a signal. Yeah, once again, different types of structures. You study the morphology of the structures and try to find out whether is it possible to have a chalcopyrite, is it possible to have a sphalerite, galena. Yeah, these are called placer deposits. Basically, what happens is when the terrain is uplifted, if there are certain places the metals are there, when it is exposed to the surface, it will start leaching, it will start weathering. So weathered process can bring important components to different parts of the geomorphic, like for example, it can bring to the valleys, the stream is there, it will carry the stream. So on the way it will deposit, they are called as the placer deposits. Most of the gold panning in many places, it is because of the weathering and as well as the transportation process of streams. Yeah, this is a model given for deposition of the uranium in the roll front. Of course, in sedimentary petrology, you must have studied all these things. When we study uranium, we will discuss. Yeah, yes, this is section to show how rocks they transfer. They give rise to different types of different fabric in the original rocks, and finally it can give rise to mineral deposits. For example, the top one is iron oxide. You can have nodular iron. These are the laterites carrying a lot of iron. This particular part is nickel. It carries a lot of nickel. So when an ultramafic rock is subjected to weathering, so this can create this type of mineral deposits. Basically, it's formed by the leaching process. Yeah, yes. This is called skarn type of deposits. Basically, skarn is a impure rock. Mostly what happens is when sedimentary rocks, when it carries a lot of calcium, limestone, when there is igneous intrusion, when there is, for example, this one, it's an intrusion, intermediate igneous rock. It can be granite, it can be granodiorite, it can be tonalite. When it is interacting with the sedimentary rocks, there can be a lot of emanation of fluids, and finally it will create a lot of skarn. The skarn can carry a lot of metals like lead, zinc, sometimes wolframite, sometimes tin, like so for example, fluoride, asbestos, graphite. So a lot of things can happen in a particular skarn environment. These are different types of skarn deposits. We will study more detail later. Yeah, these are the different type of structures you will find. If you go to deformed areas, most deformed areas, you will have like different types of veins, fissure veins. Did you study veins in structural geology? Anshul?
Yes, sir.
Did you study veins in structural geology?
Yes, sir.
So can you tell me how the veins are formed?
The veins. So, like sir, when a volcano arises, then veins
Volcano.
create. Yes,
Oh
sir.
God, oh God, oh God, where? Rhythm, can you tell
Yes,
how the
sir.
veins are formed? Can you tell how the veins are formed?
Sir, some fluid which contains these minerals,
Okay,
it can freeze into these rocks,
can
intrude into
freeze,
these rocks.
can freeze.
Uh,
You want to call it as freeze? How? When a
like
solid
it go
rock is
into
there.
the
In a,
Pore
in a,
spaces.
in a solid rock, for example, you have a solid rock, okay, highly compact, how veins can form? Because totally it's compact, no?
Yes, sir.
So how it can create this type of structures?
So the
How it
magma,
can,
magma
magma.
which contains these minerals.
No, it's all right. Not magma doesn't contain minerals. Magma contains a lot of components. When magma crystallizes, you will have minerals.
So fluid carries these minerals and it precipitates. So these.
It's okay, but you have to have the space, no? You have to have the space. For
So,
example, one by one. No, I don't want many people to talk. Can you tell who is speaking?
so Daksh. So I
Huh?
had an explanation. So Daksh speaking, sir.
Okay, please.
So because magma is high in temperature and all the rock elements have cracks and crevices in some sort of a manner, the heat can cause expansion, which in case can increase the size of the crevices. The magma can go in, make space for itself,
God,
then
oh God, oh
precipitate,
God, oh
and
God.
this formation can take.
You are mixing so many things. My Lord, my Lord. You are mixing so many things. Do you know what is syngenetic? What is epigenetic? What are primary structures? What are secondary structures? Suppose are you from anyone from Bombay? Anyone is from Mumbai? Anyone is from Maharashtra? You go to basaltic rocks, okay, they are purely formed by volcanic eruption, okay. What is volcano? Volcano is nothing but the magma that is coming to surface and it is consolidating, okay. You will find only rocks, massive rocks. Is it right? Total massive rocks. But when you go to certain places like Pune, Nasik, you will find within the rocks, you will find certain mineral like zeolites, calcite, quartz in open spaces, in cavities. Cavities are in open spaces. So these are created. So you people should understand what are primary, what are secondary. So whatever that you're seeing here, all these are secondary. So original rocks were subjected to deformation. So when it's subject to deformation, it creates open spaces. Subject to shear, for example, this one, A, B, C, D. Yeah, D you see, okay. So originally they were single rocks, but the rock was subject to deformation because of ductile shearing. So it can develop a lot of open spaces. What are the black ones that you are seeing? Originally they were the open spaces which were filled by the fluids. So you have to, of course, I do agree with you. Whatever that you are telling, something was right, but you should not mix. You should be very systematic. Formation of rock is a primary feature, deformation is secondary feature, and when the deformed rock, when certain fluids are acting, the fluids can not only magma. Okay, for example, you're talking only magma. The fluids can come from magma, the fluids can come from metamorphism, it can come from the connate waters, it can come from meteoric water, the simple atmospheric water that can percolate the deep faults. So when all this water, when it becomes part of the fluid, then it goes and fills all this place. This is called as the open space filling. These are the open spaces created by the structural deformations. Okay, you are very, very specific. I know you were able to tell something, but very careful. Okay. Anyhow, when you go to field, try to look for this type of structures. Try to look for this type of features. That's why in geology, field work is very important. Let us go to the next slide. Once again, these are also different types of fissure pattern, radial pattern, parallel pattern. Okay, so you can have different types of fractures developing due to deformation and they can be filled later. Yeah, you see, shear zone deposits. Able to see shear zones? Amit Yadav, able to see the slide? Hello, Amit Yadav, Anshika Gupta. Hello.
Yes, sir.
Not sleeping or what?
No, sir, I'm not sleeping.
Amit Yadav is sleeping. What do you see? What do you see on the screen?
Shear zones deposits.
What are shear zones? Can you tell me what are shear zones?
Sir, matlab tabular sheet-like structure or
Tabular sheets like structure. Okay. I just asked you what is a shear zone. I did not ask anything about the structure. I asked what is a shear zone.
so when we have shear stress on surface.
Okay. Okay. So what does it create? Something written here. It's a ductile shear zone. Do you know what is a ductile shear zone? Do you know what is a brittle shear zone? Did you have structural geology?
Yes, sir.
Huh.
So
Tell me.
ductile.
Hmm. ये प्रॉब्लम बाद में बताएंगे सर कुछ नहीं पढ़ाया है Because all these things were taught as a part of structural geology. So whenever you have shearing takes place, it creates a lot of open spaces. So the open spaces are filled by the lateral fluids. So that's why they're called shear zone deposits. Shear zone is a pure structural deformation. But when it is filled by certain fluids, coming either from magmatic, metamorphic, meteoric, then it will be called as shear zone deposits. And these shear zone deposits are very important. Ankit, do you find something on the screen now? Ankit? Akshat Punia?
Yes, sir.
Do you find something on the screen?
Yes, sir. Saddle reef and ladder veins.
Yeah, what is this? Just looking at the figure, what do you feel about this? What pattern it gives?
Sir, ladder
A
vein
is
is
saddle
the,
reef. Pardon?
sir, when we look at the ladder vein,
No,
when
don't look at ladder vein. Just look at the saddle reef. A. Don't look at B. Just look at A. Look at here and tell me, comment about this. When you see this as a geologist, what do you say as an earth scientist?
sir, this black space is an open, black part is an open space which is filled with liquid.
Very good. Not liquid, but by certain components. Certain
Yes, sir,
components probably must have been liquid later. It's written L. Yeah. Oh, God, no. It is basically now it is a solid which must have found by some fluid activity. Okay, done. Okay. But what is the pattern? What is this pattern? Akshat, it's a fold, Baba. It is fold.
Yes, sir.
It has
Yes,
been
sir.
folded. No, it is an anticline. So when the flat rocks are subject to deformation, compression from both the sides, it will start folding. It will form an anticline. Okay. So during the formation of folding, it can create open spaces. In that, the fluids will start moving. So it will be tectonic. So this is how when you go to the field, when you see these type of structures, people will get an idea. Okay, this must have been the process operated in this particular area. So we can expect different types of deposits. What type of process must have acted, and what is the resulting deposit? Yeah, you see, along a single fissure. Okay, whereas you have multiple veins. Okay, and this one is all replacement in a sedimentary terrain. So you see all flat. A, B, A, the third one. So here, the originally sediments, okay, slightly dipping sediment, but it created certain spaces. So the fluid has gone and it replaced. Once again, you see all replacement. So you have a lot of processes can operate to produce a mineral deposit. So we will study all these things in detail. Okay, is it right? So this today's class, it has just given you an idea that you can have different types of structures, you can have different types of morphology, you can have different processes that can operate to give rise to a mineral deposit. And we will study all in detail, one by one. Okay. So where is our representative? Raghav?
Yes, sir.
Can you summarize what we have seen today before ending the class? Can you please summarize?
Sir, we saw how veins are formed and different deposits can be found in various states of the country.
Very good, very good, very good, very good. So will you read something from books? Have you got any books on economic geology? Whether your batch, have they downloaded any book? Did you see the syllabus? Did you see the references in the syllabus? Aryan?
No, sir.
Aryan?
No, sir.
No.
Yes, sir. Hello.
I am asking Aryan to speak. There are two. One is Aryan, another is Aryan Gupta.
Sir, I am Aryan Gupta.
Okay, Aryan Gupta. Did you see the syllabus in our IIT website?
No, sir.
No, God. Please see it and see the reference books also.
Okay, sir.
I
I
know
will see.
all of you are very good in downloading books. Try to download some books. So when I come to the next class, you please download some books and inform me what books you have downloaded or what books you have just gone through. Okay. How about, have you started other classes? Your other classes have started?
Yes, sir.
Yes, sir.
क्या class start हुआ?
And soil mechanics here.
Soil mechanics. Okay, very good, teacher. Pradhan must be teaching.
Metamorphic.
Then
Metamorphic.
very good. Achha, very good, very nice. Dr. Srivastav, newly joined faculty. Good. Then, how many courses you have in this semester?
6 courses.
6 courses. Oh, that's too much. वो ज़्यादा है. क्या courses हैं? What are the courses? Let me ask Anshika Gupta.